Okay. So based from the boundary conditions, boundary condition 1, which is at x equals 1, at the roller support, deflection there is 0. So it gives us this first equation. Then for the second boundary condition, that is at x equals to 11, and that is that point, x equals 11, the deflection there is also 0. So substituting values there and the deflection equations there, it would give us this one. Now, so simplifying the second equation, so this would be negative 25 over 3 times 11 cube plus 123.75 over 6 times 10 cube minus 25 over 3 times 7.5 cube minus 25 over 24 times 5 to the 4th. Okay, so that gives us, so our second equation becomes 0 equals 16,100 over 3 plus 11C1 plus C2. Okay, then for the first equation, that would be, I'll just copy the first equation, so that would be negative or 0 equals negative 25 over 3 plus 1C1 plus C2. So we have two equations with two unknowns, C1 and C2. Solving simultaneous equations, I could just subtract this equation with this equation. So this would be C2 minus C2 is 0. 11C1 minus C1 would be plus 10C1. And this would be 0 equals 16,100 over 3 minus minus, so that's plus 25 over 3. Okay, so that would be 5375. Okay, so from this one, C1, it would give C1 equals 5375 divided by 10, so negative 537.5. So that would be our C1. Then therefore our C2, substituting that in this equation, in equation 1 or in equation 2, it would give us C2 equals minus 25 over 3. So for this case, C1 minus 25 over 3. Then you transfer it to the other side, C2 becomes 3275 over 6. Okay, now so with the C1 and C2, substitute it in these equations, it would give us the particular equations. Now our objective for this primary structure is to solve for that delta BO and theta AO. Okay, so for delta BO, that is actually the deflection at x equals what is x there? 516. Okay, so substituting this in the deflection equation over here, so let us substitute. So that would be EI delta BO is equal to negative 25 over 3 times 6 cube, okay, plus 123.75 over 6. 6 minus 1 is 5 cube minus 25 over 3. 6 minus 3.5 is 2.5 cube. Okay, then minus 25 over 24. 6 minus 6 is just 0. So this would just be 0. Plus C1. C1 is 537.5 times x is 6. Then plus C2. Plus C2 is 3275 over 6. Okay? So, let us simplify this one. Calculate everything. So that would be negative 25 over 3 times 6 cube. Okay? Then plus 123.75 over 6 times 5 cube minus 25 over 3 times 2.5 cube, then minus 537.5 times 6 plus 3275 over 6. So that gives us negative 8125 over 4. So we have the EI, put it there, so that would be delta BO. Okay, now how about for theta AD? So how do you solve for theta AD? So for theta AD, that would be the slope at x equals, at this point, so x there is 11. X 11. So substitute this boundary condition in the slope equation. So this becomes EI theta AO, okay, is equal to, okay, so negative 25, x is 11 square, then we have plus 123.75 over 2. 11 minus 1 is 10 square. Okay, then minus 50 over 2 is 25. 10 minus 3.5 is 11 minus 3.5 is 7.5. 7.5 square minus 25 over 6. 11 minus 6 is 5 cube, then plus C1, and C1 is negative 537.5. So doing our calculation, so we have negative 25 times 11 square plus 123.75 over 2 times 10 square minus 25 times 7.5 square, okay, minus 25 over 6 times 5 cube minus 5, 37.5. Okay, so we got 8375 over 12. The EI is there, so that would be our theta AO. Okay, so from this solution we were able to solve for delta BO and theta AO. So this is for the primary structure. Okay, our next step would be analyzing these redundant structures. So let's start with the redundant structure MA. So this would be the MA. Okay, so let me solve it here separately. So solving the redundant structure, solving redundant structure MA. Okay, so this one, so I'll just copy it. Okay, so hinge, then we have roller. Okay, so this is 10 meters, this is 1 meter. Okay, so due to that unit moment over here, okay, so this will deflect like this. Okay, so this would be FBA, that is the deflection at point B due to the unit load of 1 kilonewton meter over there, and this would be the slope theta or F FAA. That is the slope at A due to the unit couple of 1 kilonewton meter at point A. Okay, so we can solve for this FAA and FBA by any of the classical method also. So FAA and FBA. So let me solve this using again double integration method. So I need to solve first for the reactions. Okay, 1 kilonewton meter, so this has to be compensated with this, so that's 1 over 10, or that's 0.1. Okay, so 1 over 10 is actually 0.1. Okay, downward. So by summing of forces vertical, this would be vertical, and this is also 0.1. So I will consider my origin again here, and my x ranges from 0 to 11. 0 to 11. So I'll be considering the right segment. So if I write the moment equation, EI y double prime, and that would be this one, 0.1. 0.1, the distance would be x minus 1. So x minus 1. Okay, so that's the distance. And that is clockwise, so that's negative. So that is the moment equation. Okay, so EIY prime, that's the slope, that's negative 0.1 x minus 1 square over 2 plus C1. Then the deflection equation becomes negative 0.1 x minus 1 cube over 6 plus C1 of x plus C2. So what would be our boundary condition here? So at x equals 1, the deflection there is 0. Okay, so substituting it here, so that would be 0 equals x equals 1. X equals 1, this would be 0. So neglect about this one. So that would be C1 times 1 plus C2. So that would be our first equation. How about the second boundary condition? That would be at this hinge, and that is x equals 11. Deflection there is also equal to 0. Okay, so substituting in this equation, that would be 0 is equal to 11. So negative 0.1 over 6. 11 minus 1 is 10 cube plus C1 is 11. 11 C1 plus C2. Okay, so rewriting this equation, so the first equation, based from the first boundary condition, I could rewrite that as C1 is equal to the negative of C2. Okay, then substitute that in the second equation. Okay, so this would be 0 equals, this one is negative 0.1 over 6 times 10 to the 3. Okay, so that is actually negative 50 over 3. Okay, plus 11 C1. C1 is negative of C2 plus C2. So from there, I could solve for C2. And that is negative 11 plus 1. So that is the coefficient for C2. Then if I transfer it to the right side, so that would be 10, and that would be negative 50 over 3 divided by that coefficient. So therefore that would be over 30. Negative 50 over 30. Okay, so negative 50 over 3 divided by 10, so that's 25 over, sorry, 10, 30, negative 50 over 3 divided by 10, right? So that's negative 5/3. Okay, so that's C2 and C1. So C2, so therefore C1 would be the negative of C2, and that would be positive 5/3. Okay, so to solve for FBA, that is the deflection at x equals, this is at, how much is this? 6 meters. Okay, so 6 meters. So substituting this in the deflection equation, that would be EIY FBA is equal to negative 0.1 over 6. 6 minus 1 is 5. 5 cube plus C1. Plus C1 is 5/3. 5/3 and x is 6. Then plus C2, and C2 is negative 5/3. Okay, so therefore our FBA here is equal to negative 0.1 over 6 times 5 cube plus 5 over 3 times 6 minus 5 over 3. So we got 25 over 4 EI. So that is FBA. Okay, how about FAA? For FAA, that would be the slope at x equals 11. Okay, so substituting it here in the slope equation, so that would be EIY prime, y prime is FAA, is equal to negative 0.1 over 2. X is 11. 11 minus 1 is 10 square plus C1. And C1 is 5 over 3. So from there, FAA is actually equal to negative 0.1 over 2. Okay, over 2 times 10 square plus 5 over 3. So we got negative 10 over 3 EI. So that is our FAA for the redundant structure of MA. Okay. Now, next would be for the redundant RB. Okay, so here it is. For redundant structure RB, so I just copied this one with the 1 kilonewton over there. Okay, so due to the 1 kilonewton, so there will be reactions of 0.5 and 0.5 over here, and causing the deflection FBB here, and the slope FAB there. So these are the unknowns. Again, using double integration with x ranges from 0 to 11, origin is on the right side. So my EIY double prime equation would be 0.5 negative of x minus 1. Okay, then this one also plus 1 unit load, and the distance is x minus 6. Okay, so x minus 6. Okay, now so our EIY y prime is equal to 0.5 x minus 1 square over 2 plus x minus 6 square over 2 plus the constant of integration C1. And for the deflection equation, that would be negative 0.5 x minus 1 cube over 6 plus x minus 6 cube over 6 plus C1 of x plus C2. Okay, again, our boundary condition here is that x equals 1, deflection there is 0. So it will give us, substituting it here, it would be 0, 1, so this would be 0. No? So 1 minus 1 is 0. This would be negative, so it would be neglected. So what is left is the C1 times 1 plus C2. So call it as our first equation. And the second boundary condition is that x equals 11, that is at this point. The deflection there is also 0, no? Because that's a hinge support. So substituting this in the deflection equation, it gives us 0. Okay, so that's negative 0.5 over 6 times 11 minus 1 is 10 cube plus 11 minus 6 is 5 cube over 6. Okay, then plus C1 of x is 11 plus C2. Okay, so but from this equation I could the first equation, say this is the second equation. For the first equation, I could rewrite this as C1 is just the negative of C2. Okay, so that is the first equation. Substituting that equation 1 in the equation 2, that becomes, let me simplify this first. A negative 0.5 over 6 times 10 cube, okay, plus 5 cube over 6. So okay, so this becomes 0 is equal to negative 125 over 2 plus 11 C1, and C1 is negative of C2 plus C2. So from there I could solve for C2. Okay, so that's negative divided by 10, negative 10. So that would be negative 25 over 4. Therefore C1 is the negative of C2, that would be positive 25 over 4. Okay, so those are the constants of integration. So to solve for these unknowns, let's start with, say, FBB. So for FBB, ito yun. So that would be the deflection at x equals 6. So substitute it in the deflection equation. So that would be EI, y is the FBB, equals this one. So negative 0.5 over 6, x 6 minus 1 is 5 cube, plus 6 minus 6 is 0, so 0 lang yan, plus C1 is 25 over 4, C1 times x is 6, plus C2 is negative 25 over 4. So therefore our FBB is just equal to negative 0.5 over 6 times 5 cube, okay, plus 25 over 4 times 6 minus 25 over 4. So we got 125 over 6 EI. So this is FBB. Now what about for FAB? So for FAB, that would be the slope, right? The slope at A. And at that point A, x is equal to 11. Okay, so substituting this in the slope equation here, so that would be EI, y prime is FAB, equals this one, negative 0.5 over 2, 11 minus 1 is 10 square, plus, again, 11 minus 6 is 5 square over 2, okay, plus C1, and C1 is 25 over 4. So from here I could have FAB equals negative 0.5 over 2 times 10 square plus 5 square over 2 plus 25 over 4. So we got negative 25 over 4 EI Okay, so those are the deflections and slope at the redundant structures. Okay, so we're going to substitute all of this here. Okay, so let me substitute values. Okay, so let's start with the first equation. Okay, for the compatibility, so in the compatibility equations, excuse. Okay, so our first equation is here. So that would be delta BO plus MA FBA plus RA FBB should be equal to 0. Okay, so I'll be collecting those values there. Delta BO is here. So we got negative 8125 over 4 EI. Okay, plus MA, that's the unknown. FBA is this 25 over 4 EI plus RA. FBB is this one, 125 over 6, and should be equal to 0. Okay, so this is our first compatibility equation. Now what about for our second compatibility equation? So ito yun. So this one, okay, so this one is say delta AO plus MA FAA plus RB FAB should be equal to 0. Okay, so substituting values. So from the primary structure, delta AO is 83.75 over 12 EI. So here. Then for the redundant MA, okay, plus MA, FAA is this one, negative 10, okay, over 3 EI. Then plus RB times FAB is this one, negative 25 over 4 EI should be equal to 0. So this would be the summary. Okay, so as you can see, we have now two unknowns, MA and RA. This should be RB, sorry, this should be RB. This is RB, this is RB. So we have two unknowns, no? MA, RB, two unknowns with two equations. So we'll just have to solve simultaneous equations to solve for the reactions. So how do you solve simultaneous equations? We could just simplify this one. So let's say okay, so let me 125 over 6 divided by 25 over 4, so 10 over 3. Is that correct? So 125 over 6 divided with 25 over 4. So this would be the factor, 10 over 3. So if I multiply everything, this one with 10 over 3, so 25 over 4 times 10 over 3. Okay, so this becomes what? 8375 over 12. 8375 over 12 times 10 over 3. So it becomes 41,875 over 18. Okay. Then this would be minus. So 10 over 3 times 10 over 3. So that would be 100 over 9 EI of MA. Then for this case, it would be negative 25 over 4 times 10 over 3. It would be, again, negative 25 over 4 times 10 over 3. It would be negative 125 over 6 EI of RB equals 0. Okay, so this equation becomes this one. Then just copy the first equation. I'll just copy it. Negative 8125 over 4 EI plus we have 25 over 4 EI MA, then plus 125 over 6 EI of RB equals 0. So so add ko lang silang dalawa para ma-cancel na to. So what happens is 41,875 over 18, okay, minus 8125 over 4. So I got 10,625 over 36 EI. 10,625 36 EI. Then this one, negative 100 over 9 plus 25 over 4. It becomes negative 175 over 36 EI of MA equals 0. So therefore our MA is now equal to this divided by this. 10,625 divided by 36 divided by 175 over 36. Is that correct? No? So find this natin para sure. So that would be our MA. 425 over 7. Okay, so that is kilonewton meter, or that's 60.714285 kilonewton meter. So that's the reaction at moment A. So substituting this value of MA in this first or second equation, either of the two, let's say here, say MA times 25 over 4, then minus 8125 over 4. So you transfer it to the right side, times negative 1, then divide it with this. So divided by 125 over 6. So our RB becomes 555 over 7. Okay, so that's kilo newtons, or that is 79.2857 kilonewtons. Okay, so that's it. So after solving for this moment at A, reaction at B, so going back to the original beam, knowing the moment, knowing the reaction at B, so by statics you could solve for RA and solve for RD. So by statics, so you could solve summation of, say, moment ka sa A equal to 0, so you could solve for RD. Then if you sum forces vertical equal to 0, you could solve naman for RA. And that would be our final answers. Okay? So I hope you learn something from this long solution. Okay, so this would be the solution for this problem using method of consistent navigation. Thank you.